So the first thing we're doing is state whether each function has a max or a min value, max or a min value. It's supposed to say, or determine the max and min value. So what about this first? Oh, the first one's so easy, it's pretty much done for us. Does it have a max or a min? What? Before we even do this, why do we graph? We spent a few days graphing. Why do we graph? Because it's annoying and your teachers don't like you and they make you do it even though you hate it? Yes?
To visualize it.
To visualize. What a great answer. It was almost like I whispered it to him ahead of time or something. I didn't though. To visualize. The whole point is that you can visualize these curves. You can see them in your mind or maybe sketch them or something like that, and it helps you solve these problems. If you remember, do you remember the quadratics units in grade 10 and you did all these word problems? Some of them, remember the revenue questions, maximizing revenue or maximizing area, or two numbers have a sum of 25. Their product is a maximum, find the two numbers, or something like that. Remember those ones at least vaguely? And then, anyway, there's all different kinds. And the answer to those questions is somewhere on the graph. So if you go down, if you look at the bottom, there's the quadratic. Everything we're doing is still working with quadratics. So all the stuff that we're doing will have a graph. Whether you graph it or not, it has a graph. And the answer to the questions that you're going to be asked is somewhere on that graph. And so if you can visualize, you can be like, oh, the answer is here, this point. Then you have to figure out what that point is. Or the answer is this point. You got to figure out what that point is. Or the answer is this point. You got to figure out what that point is. And then there's a skill involved in figuring out where that point is. But the first thing you probably want to figure out is which property of the graph is it. So how do I look at this question right here? Y equals negative 0.5, x plus 7 all squared plus 20. How do I visualize that and determine whether that graph, without graphing, has a maximum or a minimum value? What do you think?
It's a negative, so you know it'll be upside down, so it'll be a max value.
Right. This has a maximum. Okay? So this opens down. Because of that negative sign. Therefore, it has a maximum. See how that works? See how we spend all this time graphing so that we understand how the different values, the A value, the H value, the K value, how it affects the graph. And then we can use that without even graphing to just visualize what would this look like. So it opens down. What else? Determine the maximum value. So this one has a max. What is the max value? And how do you know? Brooke? Why? What does the 7 do to the graph? Anybody? Shifts where?
To the left.
Shifts sideways. So that's not going to tell us about our max or min, is it? So what else could it be? Somebody other than Zach. Jess, do you know? 20. Why is it 20? So it's shifted up 20. And that's as high as it's going to go. Does that make sense? So the vertical shift is 20. I'm going to scribble on this a little bit. But shift up 20. Is that number there? Therefore, max of 20. It says, and the question says, determine the maximum value and the x value where it occurs. So if I do, and you can just watch, you don't have to actually do this. If I do a quick graph of this, it would have a shift. Oops, I didn't do a very good job drawing those. A shift to the left, 7, and up 20. And opens down from there. So that's something like what the graph would look like. There's no scale. I have no idea exactly what this one looks like without graphing it properly, but that's a quick sketch. I can see that it has a maximum. I can see that the maximum is 20, and where would the maximum occur? What's the x value where the max would occur? -7. So that visualization process allows us to answer these questions. Now, this question was just a math class question, but it turns out all the word problems we're going to look at, all the applications, and this is true in the real world as well, are exactly the same. They're asking those same questions. They're just asking them in a different way. So I'm going to say shift left 7, and that's this thing. See, I'm going to scribble all over this. Therefore, max occurs when x equals -7 is how we would usually write that. Okay. What's next? Question B. What's different about this question from question A? That's really important. Ah, how do you know that? It's positive. Very nice. So the A value is positive, so it's going to have a minimum. We know that already. What else? It's not in what we call vertex form. So people would be like, A is 4, and A is 4, so that part's right. And people might say H is -2 and K is -1, but that's wrong. H is not -2 and K is not -1. It's not just the first number, the second number, and the third number. It's when it's in this form, right? So I'm going to make a little note of that. You might want to do the same thing. Not H, not K. So we don't know how to solve this one because we can't, it's not in vertex form and we don't know how to put it in vertex form, do we? Wait, we just spent 2 days learning how to do that. So what do? Huh? Yeah, we do what's called completing the square. Exactly right. That's, again, why we were practicing that. So how do I do completing the square for this one? I have to factor out the 4. And 4 doesn't even go evenly into 2. So what in the world was going on here? You still take the whole thing out. So x squared, what is -2 divided by 4? Do it on your calculator. You don't have to do this stuff in your head. Do it on your calculator. It's a half, right? 2 divided by 4, 2 over 4, that's a half, so -0.5. Decimals are great with this stuff. So one thing we're practicing today is we're going to see some decimals pop into the picture. How do I find the number that I use next?
Just a quick question.
Yeah.
Do you ever keep it as a fraction? Like if there was like an easy fraction, like a 1/2.
Yeah, you could keep it as a fraction. That's entirely up to you. The best answer to that is, let's say it was like a third, then to be perfect, you'd have to keep it as a fraction, but we're going to kind of avoid those for now, so people could choose to use fractions or decimals. But if you can do it in fractions, that's all the better. What do I do next?
You divide -0.5 and then square it.
Right, so I still do the same thing. Even though it's already a decimal, I divide it by 2. So -0.5 divided by 2 is -0.25. It's a quarter. Do it on my calculator. I'm not doing this in my head. I'm doing this on 0.2 divided by 2, 0.5 divided by 2, and then square that number. And I get plus 0.0625. I'm going to keep all the decimal places, not rounding, even though it's kind of a disaster. What do I do with that number? I add it and subtract it. And that's the first step of completing the square process, right? Then what do I do? I take the -1 out. What do I have to do when I take the -1 out?
You multiply 0.0625 by 4.
Yeah, I multiply by the number out front, whatever it is. So I still have that number on my calculator, so I multiply by 4, and that is -0.25. And then I can write this the finished way. So it's going to be x minus 0.25. Remember, I cut that in half. Keep the same sign. Negative 0.25 minus 1 is minus 1.25. Decimals, fractions, a little bit messier, a little bit nastier, but the nice thing about completing the square is it's the exact same process every single time. So don't get confused like, oh, it's a decimal, it's different. No, exactly the same thing every single time. And you've been working on that for 2 days, and I can see walking around with your learning goals from yesterday and from today that you're very good at this. So don't lose your confidence in that sense now. Now we're supposed to be determining the max and the min value, or the max or the min value, and the x value where it occurs. So we're already told that it has a min because the number out front is positive, so it opens upward, so it has a minimum value. The minimum value is the vertical shift.
Negative 0.125.
Negative 1.25, very good, yeah. Min at negative 1.25. That's the vertical shift. Visualize it, folks. Don't just memorize. Visualize. Think about what those, when you get it in vertex form, think about the A, the H, and the K. The A flips it because of the sign. The K moves it up and down, so that's telling you where the max or min value is. And the H and a min at, that should actually say a min of, doesn't really matter, but min of negative 1.25 at x equals positive 0.25. The horizontal shift. That's where the vertex occurs. The minimum occurs, or the maximum, always occurs at the vertex of a parabola. That's where the min or max occurs. And the values of the vertex are the horizontal shift and the vertical shift. Okay, let's try another one. Oh, this is supposed to say a half. So can you fix that? 1/2. So the first one I divided by 4, and I got a decimal. Now I'm dividing by a decimal. Without using your calculator, I don't need, unless somebody wants to give this a try. In your head, what is 6 divided by a half? But what I'll tell you is most people's intuition is wrong. So unless you're really good at this stuff and you kind of know the trick, your intuition might be wrong. In fact, what do you think somebody might say if I say, what is 6 divided by a half? People might say 3. Don't you agree? And some people would be thinking 3. Why is that wrong?
Because that's just half of 6.
That's half of 6. That's 6 times a half. What does 6 divided by a half mean? How many times does a half fit into 6? So how many times would that be? Yeah, because I can fit a half into 1 twice, and then a half again into 2 twice, and then half again into 3. Like, right? How many times does a half go into 6? It's going to be 12 times. You don't have to be able to do this in your head, but it's interesting how people think fractions are really hard, and we have all these rules for like dividing fractions, and it's actually kind of simple if you think about it the right way. If I take, so don't worry about this. This is just a sidebar. If this is 0 and this is 6, so I've got 1, 2, 3, 4, 5, 6. How many times does a half fit into 6? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right? 2 per number. I don't know. I think that's kind of interesting. Think about it that way. So, but use your calculator. If you want, you use your calculator, and I would just do 6 divided by 0.5 or a half, because this is 0.5. Don't forget that. You can turn fractions, if they're nice fractions, into decimals if you prefer. And I get 12. So I take out negative 1/2, and I get x squared, and a negative divided by a negative should be a positive, so plus 12x. So all of that talking was to make us realize that in a question where there's a decimal out front, that middle number is going to get bigger. Yesterday, whenever we did this, take a look. Here's some examples we did yesterday. I did 60 divided by 3, which is 20. So it always got smaller, and people get used to that. But today, it was a different example, so it got bigger. I take half of 12, which is 6, and square it, add it, and subtract it. Y equals negative 1/2 x squared plus 12x plus 36. What do I do with the negative 36 when I pull it out? Multiply it by negative 1/2. Again, use your calculator. If you make mistakes doing this in your head, use your calculator. This time, the number is going to get smaller again. 1/2 of 36 is 18. So it's plus 18 minus 15. And then we can write the final version. And then we can answer, does it have a max or a min?
Max of 3.
It's got a max of 3 because it opens down because of the negative, so it's been flipped. So it's got a max of 3, and it occurs when x equals, so it's the vertex where this happens. So where is the vertex been shifted to? Thank you, negative 6. I love it. Right? It's always goes the wrong direction. Okay, you try D. Okay, so what's the number that I need? So I do this. Hold on. Let me get caught up here a little bit. So I do this. I take the 0.05 out, bracket, x squared. What's the number that I get inside? 40. Did anybody else get 40? So negative 40, very good. 40x, half that is 20. 20 squared is 400. Minus 400 plus 10, 0.05x squared minus 40x plus 400, bracket. Negative 400 times 0.05, negative 20 plus 10, and y equals 0.05x minus 20 squared, and then negative 20 plus 10 is minus 10. Okay, very good. So this one has a minimum, it looks like, because it's opening up, because it's not flipped. So visualize min of shifted down 10, so negative 10, when x equals, and it's shifting right 20, so positive 20. Everybody good? All right, so there's a few of those to practice that have decimals in them as part of the practice for today. And now our first example is a little bit different because we don't even have an equation or any numbers or anything like that. It just gives us a graph. But again, this is part of the visualization process. So most of the questions are not going to do this. They're going to give you numbers. You can sketch the graph if you want, like I did for that first one up there. A little sketch like that might be helpful. And I'll probably do that in some of the questions that we work on throughout the next few days. But this one's giving it to us. And it says the graph below represents the height of a ball over time. Use the graph to determine the maximum height of the ball. So the graph, this is a nice one because a ball, when you throw it, or an eraser, right? Everybody watch? Actually looks like a parabola. It actually looks like the path that it follows. But that's not true of every kind of question that we do. Some of them don't look like revenue. Maximize your revenue. That doesn't look like it looks like money, I guess. I don't know. It looks like change in your pocket or something, right? So those ones are harder to visualize. Whereas a ball being thrown actually looks, because it follows a parabolic path, so it actually looks like a parabola. So this is a nice one to start with. But this is a graph that represents the height of the ball over time. So this is the height, and this is time. I don't think it tells us, but presumably in seconds. Oh yeah, it says how many seconds, so it's in seconds, I'm sure. And we're going to say height is in feet. Why not? So watch. If I go 1 second, so there's 1, how high am I? That's how high I would be. I'd read it off that graph, right? That's how this graph works. So where does the maximum height of the ball occur? I think it's obvious, but where does it occur?
15 feet.
Yeah, but it's at the vertex, right? Which is 15 feet. So it's got a max height of 15 feet. And notice that all the questions, not quite every question that we're going to come across, but right now the questions focus on the vertex. So the answer to most of the questions we're going to explore have to do with the vertex of the graph. So you got to always be thinking about the vertex, right? So I'm even going to say like this comes from the vertex. Then it says, after how many seconds did the maximum height occur? So what am I going to do? I'm going to follow that down. And there it is. It occurs. What is that point? Ellie? It's a little bit tricky because you got to read that scale, right? Yeah. 1.5, it occurs after 1.5 seconds. And then this is another interesting question. At approximately what height was the ball thrown from? What's that one, Sarah? About 4 feet. And what's that called? What property of the graph? We haven't talked a lot about this one, but this is one you know from grade 9 and grade 10.
The y-intercept?
It's the y-intercept or the vertical intercept or the h-intercept, whatever you want to call it, but like the y-intercept. So that's going to be important because we're going to talk a little bit about that. It was thrown from about 4 feet. Looks like it might, why did I put that in brackets? Looks like it might be a little bit less than that, but it's hard to tell. And that's not the point because normally we're not reading this off a graph. And that's from the y-intercept. So we need to learn how to find the y-intercept as well as how to find the vertex, which we're going to do. But we're going to run out of time, so we're going to stop here for today. I am going to give you your practice because you can do a little bit of it to be ready for tomorrow.